Okay, let's get started for the day. So, last time we took a look at functions and how to find the inverse function, as well as how to find the range of a function using that inverse function. And today, what we're going to be doing is talking about combinations of functions. So last time I mentioned that, again, if we think of functions as being like machines, an individual function could be, any kind of thing that we put an input into, and it processes it and then gives us an output. However, we can put these functions together in various ways using various operations to make them bigger machines, things that do more complex work. So I used the metaphor of a car. Maybe our individual functions are things like the transmission and the starter and the engine and pieces like that. They're all machines that do some kind of work. They have an input and an output. However, if we put all these things together, we get a more complex machine that has a more complex purpose, like a car. Okay, so let's take a look at what this is like. So let's say that we have two functions, f and g. And let's say that we plug in a number for these functions, 2. So we're plugging in 2 for both of these functions, and they're each going to give us something out. So f of 2, if we plug in a 2 into our f function, maybe it gives us something like 5. And then if we plug in 2 into our g function, maybe it gives us 3. Okay? So again, 2 is the input and 5 is the output here for f. Similarly, for g, 2 is the input and 3 is the output. So they're processing 2 in a different way and getting these two different outputs. Okay, now we can put this all together using something like f plus g. And so f plus g is where we're adding f and g together. And so if we have f plus g of 2, what we're saying here is take the outputs for f and g where we have 2. So the output for f when we put in 2 is 5. And the output for g when we put in 2 is 3. And so that would mean that if we add these two together, 5 plus 3, of course, is 8. So f plus g of 2 is 8. Okay, so I'll just go through this one more time to explain it again. F and G are different functions. They process numbers in a different way. So we can put in the same number into both of them. We can plug in 2 into F and 2 into G, and they will give us two different numbers, 5 and 3 respectively. Now we can combine F and G using addition. So we can have F plus G. And so if we do F plus G at 2, so both of them were getting 2 for their input, and we want to see what their output added is. So F plus G of 2, That'd be 5 plus 3, their outputs added. And if we add the outputs here, 5 plus 3 is 8. Okay. Well, we can do a whole lot more than add. We have a lot of other operations out there that we can do. For instance, if we can add, we can definitely subtract. So f minus g is the same idea. If we do f minus g of 2, we're saying, okay, what are their outputs at 2? So again, that would be 5 and 3, but this time instead of adding them, we're going to be subtracting them. So 5 minus 3. Okay, well 5 minus 3, of course, is 2. Okay, well, we can add, we can subtract, we can probably multiply and divide. So f times g of 2 that would be 5 times 3. So 5 times 3, that's 15. And division is the last one we can do here. F divided by g of 2 that would be 5 divided by 3. And 5 over 3 is just 5 over 3. We can write it as a mixed number. We could write it as a decimal. I'm just going to write it as a fraction, though, as a improper fraction. So 5 over 3. Okay. So this is really what we're talking about when we are combining functions together. We're using various different operations, and what is going to happen is that their outputs are going to combine using that operation. So again, like f, I don't know, times g. If f of 2 is 5 and g of 2 is 3, and we want to do f times g of 2, then we do 5 times 3 to get 15. Okay. So I'll pause real quick for any questions we may have. Okay, I don't see any questions, so I will move on. And real quick, I want to import a graph, so hold on for a moment. Okay, so I've got a graph here. So let's say we have two functions graphed on this grid. I'll put one function here and another function, let's say, oh, whoops. Take that function out. Okay. So let's say that I have one function looks like this. And another function that looks like this. Okay? So I'm going to go ahead and label these F and G. So let's say that this one is F. Oops. Let's make that a little bit bigger. Let's say this is F of X. And this one here is G of X. Okay, so what if we want to find the same kind of thing like we did here, where we had, you know, F of 2 and G of 2. Okay, so let's say that we want to get, I don't know, -5. Let's do -5. So F of -5, what we're going to do is we're going to say, all right, we're plugging in -5. We need to know the output. So what does this output when we have -5 for our x? Well, we find -5 on our x, and then find where this crosses -5, and it crosses at +3 for the y. Okay, so our output is +3. Okay, same thing for g of x. Oops. G of -5. We're going to find -5 on our x and then scroll down until we see where that crosses, and it crosses at -4. So now we have our input and our output. Our input again was -5, and we found our output at 3 and -4 for F and G. So now we can do the same thing that we did before up here, where we did, you know, plus, minus, multiply, and divide. So if we want to do plus, that would be, let's see, 3 plus -4. 3 plus -4 is -1. if we wanted to do minus, that'd be 3 minus negative 4. 3 minus negative 4, that's 3 minus negative is really positive, so 3 plus 4, 7. F times g, so 3 times negative 4, that's negative 12. And f divided by g, 3 divided by negative 4, that'd be negative 3 over 4. So we can do the same thing as we had here with just points on a graph. So we can combine functions if we just have the graph. We don't have to have, a set of numbers. We don't have to have a set of points. We can find those points on the graph and do the same thing. Okay? And I know that Hawks will show you something like this. They're not always going to be straight lines, but it's the exact same idea. You will just say, all right, if we want to plug in, like we did here, negative 5, just find negative 5 on your x coordinate, and then find where that crosses your graph. So here it crosses the graph at 3, so we record 3 for our output. Okay. So far what we've been doing is we have known an input and an output. Alright, what if we don't know an input and an output? What if instead we want to be able to predict different outputs given an input? So let me show you what I mean. Let's say that instead of having, f of 5 equals something, let's have f of x is just some function, like x plus 2. And maybe we have a g of x that is x squared. Can we still combine these? Can we still add, subtract, multiply, and divide these? Yeah, absolutely. All we need to do is we need to say, all right, f plus g of x is going to be f of x, which is x plus 2, plus g of x, which is x squared. And that's it. So we have our f of x, which is right here, and we have our g of x, which is right here, and we're just adding between them. That's it. So now if we want to find something like f plus g of 3, so if we want to plug in 3 into this function, all we would have to do is take that input, 3, and plug it in anywhere that we have an x. So, plug in a 3 for that x. And plug in a 3 for this x. And now we can go ahead and use our simplifying methods and figure out what this value is. So order of operations, of course, we want to do 3 squared, so 3 squared is 9. And then let's see, only thing else we have left is add, so 2 plus 3, that's going to be 5. And then 5 plus 9 is 14. So f plus g of 3 is 14. So here we don't have to rely on knowing an input and an output. Here we can find just a general expression that it represents the f plus g. And then we can plug in whatever we want and we can get the outputs. Okay, so I'll pause again for any questions we may have. All right, I'm not seeing any questions, so we'll move on. Let's try another one of these. Slightly more complicated. Let's try f of x equals 3x plus 2, and g of x equals, let's say, x plus 7. And what we want to find is f times g of x. Okay, so just like before, what we're going to need to do here is we're going to need to take f of x and g of x and combine them using this operation. Now before it was addition, so we just had to add the two. Here we have multiplication, so we're going to need to multiply 3x plus 2 times x plus 7. Okay, well, you can probably see where this is going. We need a FOIL. So let's go ahead and get right on in there. 3x times x is 3x squared. 3x times 7 is going to be 21x. Then 2 times x is 2x. And 2 times 7 is 14. Okay, So there's our f times g. We still need to simplify this, of course. So 3x squared. Then we can combine these two like terms to make 23x. And then plus 14 just drops down. Okay. So f times g of x equals 3x squared plus 23x plus 14. There's our new function. So let's try plugging something in. Let's do, I don't know, -1. So f times g of -1 equals 3 times -1 squared plus 23 times -1 plus 14. Okay, so 1 squared, or sorry, -1 squared is 1. 1 times 3 is 3. -1 times 23 is -23. And then plus 14. So 3 minus 23 is -20. And let's see, -20 plus 14 is -6. So f times g of -1 is -6. So again, we can combine these functions together using operations to get a bigger function, just depending on what we want to do between these two functions. And, that's just going to take knowing what the real world application is going to be for what you're trying to do. Okay? So now I want to show you something new. We've done add, we've done subtract, we've done multiply, we've done divide. There is another way that we can combine these functions together, and that is with a composition of functions. So let's take a look at that. So again, let's say we have f and g. And f of x is going to be, let's say, x plus 3. And g of x is going to be x squared. And so again, what I want to do is I want to do a composition of functions. Now this means something completely new. So if you see something like this, f, and then an open circle, that means composed of g of x. What this means is that we're going to have f of x, so x plus 3, but we're going to open up that x to plug something in there. So we have f of x right here, but we're going to compose it of g. And what that means is that we're going to take g of x and plug it in for the x in our f. So again, our framework here was f of x, x plus 3. So that's our framework here. And for this x that we have in f of x, we're going to take this g of x and plug it in. So this is really, like we said, f of x, but we composed g of x into it. So now, f composed of g of x equals x squared plus 3. Okay, so nothing too terribly crazy. It's just, again, we're taking f of x and plugging g of x into there. Can we go the opposite direction? Can we do g composed of f? Sure. Same idea. So if we have g composed of f of x, this time g of x is our framework. So x squared is going to be going down here. That's our framework. But again, that x is going to be opened up so we can plug something into it. So we've got our framework, which was g of x, and g of x is x squared, so we have our x squared. And we're going to plug f of x into there. So f of x is going to go into here. Okay. Well, we need to simplify that. So g composed of f of x, if we square this out, that's going to be x squared plus 6x plus 9. So we get two completely different things here. When we did f composed of g, we just got x squared plus 3. That's it. When we did g composed of f, we got x squared plus 6x plus 9. So obviously these are going to get two completely different answers. So I'll pause for any questions we may have. Okay. I'm not seeing any questions, so I'll move on. So I want to show you another one of these. Another one of these composition of functions. Very similar to what we just did, but they're going to do something interesting, so keep a sharp eye. Okay, so f of x this one we're going to have 3x plus 2. And g of x we are going to have x minus 2 over 3. Okay, so at first glance, there might not be anything apparent about these two functions. They look like normal little functions. However, notice, first of all, they have the same numbers in them. We have 2 and we have 3. Also, this one takes x, multiplies it by 3, and then adds 2. This one takes x, subtracts 2, and then divides by 3. So what are these? These are inverse functions. They are the same operations with the same numbers, just in reverse. They are opposites. So these are inverse functions. So what happens when we compose inverse functions? Something interesting, actually. So let's go ahead and see what happens. So if I do f composed of g of x, again, what that means is I'm going to take f of x, 3x plus 2, and use that as my framework. So 3x plus 2, here it is. We just open up the x so that we can plug this into it. So g of x, which is x minus 2 over 3, is going to go right here. Okay. So now let's go ahead and simplify this and see what we get. Because again, it's going to be kind of interesting what happens here. Okay, so first things first, following our order of operations, we don't have anything we can do inside the parentheses. We don't have any exponents we need to take care of. We can multiply, though. So 3 times x minus 2 over 3, well, this is being divided by 3, and then we're multiplying by 3. That's going to cancel. And so now we have f composed of g of x equals x minus 2 plus 2. Well, that means that if we have the minus 2 and the plus 2, those are also going to cancel. And so f composed of g of x equals just x. Everything else canceled, which makes sense. You know, if we say that inverse functions do the exact opposite of each other, well, those opposites are going to cancel, and we're just going to be left with x. Okay, well, let's just make sure that this works, and let's do g composed of f as well. So opposite directions time, g composed of f. We know that the last time that we did this, where we did f composed of g and then g composed of f, we got two different things. So maybe this will give us something different. So g is x minus 2 over 3. So again, we're going to open up parentheses to plug things in for x. Minus 2 over 3. Oops, forgot my equal signs here. Okay, and then plug in f here and for x. You know, I don't really actually need those parentheses here. Thinking about our order of operations, we don't have anything inside the parentheses that we need to do. There's no power on these parentheses, and we're not multiplying them by anything, so I don't actually need the parentheses here. Again, it's just good practice to do that, though, because anytime you plug in something for a variable, you need to have those parentheses just to make sure that you have the right operations going on. So if we ignore the parentheses here, we have 3x plus 2 minus 2. Well, that means that those are going to cancel. The plus 2 and the minus 2, they cancel. So now we just have g composed of f. Let's try that again. Composed of f of x equals 3x over 3. Well, yet again, we are multiplying 3 times x and then dividing by 3, so those 3's are going to cancel, giving us g composed of f of x is just x. So, yeah, we actually got the same thing here. F composed of g, everything cancels out and just leaves us with x. G composed of f, everything cancels out and leaves us with just x. So this is actually a nifty way that you can check and see if two things are inverse functions. If you compose these functions of each other and everything cancels and just gives you x out, nothing else, just x, then they're inverse functions. And again, that's because inverse functions do the opposite of each other. So like we said at the start of this example, f of x here takes x, multiplies it by 3, and then adds 2. Then g of x does the opposite. It takes x, subtracts 2 first, and then divides by 3. The exact opposite in the exact opposite order. So I will pause for any questions we may have. Okay. I'm not seeing any questions, so that will do it for today. Now, we are getting towards the end of the semester, and y'all need to start thinking about going to, or calling Lobo Den. Guess you can't actually go there, and trying to register for the next semester. And you're going to need to know your grades. So I will get those grades calculated up and be sending emails out tomorrow. Okay? So watch your inbox for your grade tomorrow. And again, be sure to, at some point pretty soon, call up Lobo Den and try to register for your classes for next semester. I do know that the summer semesters, we're going to be doing the same thing that we're doing now. We're going to be doing distance learning just because, COVID-19 still is pretty prevalent. And so the university is just trying to keep everybody safe, and we're going to be doing distance learning for the summer semesters. That's summer 1 and summer 2. But the plan going forward is that in the fall semester, we should be back to a normal system. So we should be back to in class. Everybody can come back to the university in the fall. So keep that in mind for your plans. Again, grades should be coming to you in an email tomorrow, and register for classes as soon as possible. Other than that, I hope you have a great day, and I will see you later.